channel. So if you could not record, let us, we'll do it, and we'll make sure that it's available to everybody. So in that context of what a global studio could be, we're deliberately not defining it yet because we'd like to work with everybody who's joined us today to think about ideas of what people could do together online to address the issue of design in a post-COVID world. So if you've got thoughts, you are more than welcome to share them with us. If you would like to participate, you are very welcome to do so. And I'm also hoping that I might be able to reach out to some of the organizations we've been dealing with over the last few months to see how we could all make a little bit of contributions, and then we can actually get a lot of matching back in return. So we've got a very interesting lecture today, which Dr. Henry Sang is going to introduce. And I do want to give a shout out to Henry because he's been working very hard to make all of this happen, and it's been turning out incredibly well. But the thing that we like to do in each of these sessions is also think about what's going to happen next. So I'm very pleased that our partners at Open Architecture in South Africa have worked with one of our faculty members, Kristen Kornienko, to help develop and put in place the next lecture in this series, which will be by Dr. Sachaba Mape, who will be talking about drawing creepy places representing liminal ritual spaces of Kuruman in South Africa. So we'll talk a little bit more about that event at the end of the session. But in the meantime, I'm really looking forward to this one, but I will help and get this thing moving and pass it over to Henry. Henry, over to you.
Yes, thanks, Douglas. So welcome everyone to today's global lecture series. We are very happy to have two of our own faculty members presenting to you today on the topic of mass timber design. Just a quick introduction of our speakers today. Both of them are very talented educators, but also they possess a wealth of experience as practitioners, especially in using mass timber in their work. Veronica Madonna is a registered architect and a member of the Ontario Association of Architects and the RAIC. She has over 16 years of professional experience working on award-winning projects in Canada and overseas. Prior to joining the RAIC Centre for Architecture at Athabasca University, Veronica was a principal architect with Moriyama Teshima Architects based in Toronto, leading community-based projects for a number of leading post-secondary institutions in Canada. She formed part of the leadership team for projects such as the Arbour at George Brown College and the Honeybee Research Centre for the Ontario Agricultural College at the University of Guelph. Both recent recipients of the Canada Architects Awards for Design Excellency. Her work has also been published in a number of architectural journals across the world and has participated as panelist for a various number of conferences, including the Canadian Green Building Council. And Veronica is active in her local community volunteering for the Toronto Society for Architects, and also sits as on the Professional Advisory Committee at Ryerson, where she has also taught and mentored over the years. Her focus in research and design is in mass timber and passive strategies, as well as the changing landscape of teaching and learning spaces. Then we have Trevor Butler. Trevor is an engineer and assistant professor at Athabasca University. He is the principal of the firm Archineers, a qualified as both civil and mechanical engineer with over 25 years of experience, leading to delivery projects focused on sustainable and regenerative design. He takes a whole system approach to design, combining passive climatic benefits of each site with the construction program to bring out the best solutions for his design client requirements. Trevor has a track record of innovation and sustainability and was the engineer of record on Canada's first passive house certified non-residential building, which is the daycare at Okanagan Okanagan College. His creative and detailed approach to design and analysis enables the performance of innovative engineering solutions to be proven as a significant step towards net zero energy and regenerative building design. So without further ado, I'm going to pass you to Veronica, who will do the first part on her work, and then Trevor will present second. And before we start, I'm just going to ask everyone to turn off your microphones and your videos. And if you have any questions, I would like to ask you to type it in the chat box, and we will address to them at the end of both presentations. So thank you very much, and I'm going to pass it to my colleague, Veronica.
Great. Thank you, Henry, and thank you, Douglas, for that introduction. Before I begin, I just want to make sure that my slides are advancing correctly. Can everybody see them? Yep, perfect. Well, good day, everyone, and thank you for joining us today for this global studio lecture. Today, Trevor and I will be speaking about our shared experiences in using mass timber, the innovations that are happening around the world, and the design considerations that we've learned along the way. Now, architects around the world are embracing the use of mass timber and pushing the limits, forming a path for future possibilities. It's being celebrated as a demonstration of sustainability with its inherent qualities to store carbon and the potential to have positive impact on climate change. Innovations in mass timber can be seen in cities around the world, and it's being celebrated. And its beauty and warmth have proven to have biophilic and healing qualities. The heights and limits of mass timber are being raised with advancements of digital fabrication, and our understanding of key considerations such as fire resistance and lateral stability are being explored. Now, the use of wood and building material has been around for hundreds of years, and these two examples date back to almost 1,000 years ago, where its heavy timber structure have withstood major events such as earthquakes. Both of these buildings would be considered tall structures in today's standards. And in the mid-20th century, the limits of heavy timber were being pushed in different ways. This airplane hangar in Tillamook, Oregon was built in 1942. It's a parabolic wood truss dimensioning over 300 meters long, 90 meters wide, and 58 meters high. It still remains today as the world's largest clear span wooden structure in the world. And architects like Gaudi were also experimenting with wood structures, as seen in one of his early works project on the image of the left. And as testing and demonstration projects occur all over the world, codes and regulations are changing to allow the greater use of mass timber in construction. Canada is part of this pact and is leading the way. Just in the last 10 years alone, building codes in Canada and around the world are changing. In 2020, the Canadian National Building Code is expected to permit 12-story structures of mass timber. And in 2021, the International Building Code is expected to permit buildings of 18 stories. In considering the need to densify many of our urban centers and provide housing for people around the world, tall applications are being explored. This hotel in Norway is currently standing as the tallest mass timber structure in the world at 280 feet tall. Projects like Sidewalk Labs in Toronto were exploring the idea of sustainable communities with buildings made out of mass timber. The PMX model building, which you see on the right, was proposed at 35 stories tall. Now, although this project is no longer being built in Toronto, lessons learned on how mass timber reacts at heights can be applied to future projects. And the sky is the limit. This is a proposal for a wooden tower with a height of over 1,100 feet that's proposed in Japan, is expected to be built in 2041. This would be an extraordinary example of mass timber construction if built. But the advancements of mass timber are not just in tall applications. Mass timber is being explored in long span and expressive structures all around the world. But for me, the reasons for using mass timber are rooted in its potential ability to make an impact on climate change. This is an image taken at the Toronto Islands in 2017, where we experienced so much rain that year that it flooded most of the island. Now, for those who are not familiar, the Toronto Islands are home to many, and it's a parkland for the city to enjoy. The island flooded that year, and in fact, it's been flooding every year since. We know that with climate change comes more extreme weather events, and that could bring in disease and famine, and as well, it could render many parts of the world uninhabitable. It's important to note that buildings currently are a major contributor to carbon emissions, and currently it's estimated that buildings in their operation and material and construction constitute to about 40% of the output of carbon emissions. We know that wood has the ability to sequester carbon, and in fact, 1 meter cube of wood can sequester about 1 ton of carbon dioxide. This can make a huge impact in terms of climate change. Next, I'd like to share 2 projects that I've been involved with that are examples of Canadian innovation and contributions to mass timber advancements. The first is the Arbour. The Arbour is located in Toronto, Ontario, Canada. It is a 10-story net zero carbon mass timber building for George Brown College at their waterfront campus. When built, it is projected that this will be the tallest timber academic building in the world. It is a project by Moriyama Teshima Architects and in association with Acton Austri Architects. It uses a long span cross-laminated timber structure and houses 2 solar chimneys for passive natural ventilation. Its team comprises of the leading Canadian experts in the field of mass timber, sustainability, and fire engineering. The Arbour began in 2018 in a call for an international design competition by George Brown College. The objective of the design brief was to provide a low carbon building that was net zero in its performance. The site is located along Toronto's waterfront community, and it's 1 block away from Lake Ontario. So resiliency in design was critical objective of the Arbour. The design concept of the Arbour was to take a dense structural system like mass timber and breathe room into it for social interaction spaces. The building has a 3-story learning landscape that starts at the street edge, and then a series of 2-story breathing rooms that form the gathering spaces along the, leading up towards the building. These breathing rooms also flank the 2 solar chimneys that are on either end of the Arbour. A key consideration was that the program required a number of classroom spaces. Now, it's imperative that a structural grid allow for at least a 9-meter span in one direction for classrooms to work properly with view angles and whatnot. This was a challenge for mass timber as it typically requires great depth to span these types of distances. The principal elevation of the Arbour faces north, and it's located on a tight urban site. The building has a prefabricated exterior, which provides a durable and robust envelope for the mass timber, and the angle of the roof is purposeful and is sloped to the south to provide an armature for solar panels. The peak also extends the solar chimney above the last floor served to maintain pressure for the natural convection that will happen inside the solar chimney. Along the street edge, the building opens up to the public and becomes a space for students and the community to interact. The mass timber can be experienced both inside and outside the building, and the entrance is located underneath one of the solar chimneys, putting the sustainability agenda front and forward. When you enter into the building, the learning landscape is the first room that you come to. Its structure rises 3 stories. The Arbour is designed with approximately 40% exposed mass timber and is concentrated in the public spaces. The rest of the areas will be encapsulated with 2 layers of fire-rated gypsum board. This forms part of the alternative solution for the building code approvals. The mass timber forms part of the living laboratory for the departments of architectural technology and computer-aided design that will be occupying this building when complete. And also the materials provide a sense of warmth and promote wellness for students and the community to enjoy. This sectional perspective shows how the collaboration spaces and expression of mass timber permeate the building vertically through the public spaces. This is an image of the breathing rooms, and as you can see, one of two solar chimneys to the left of the image. It is a glazed wall and a series of heat shelves to heat up the air inside the solar chimney to create natural convection and push the air up through the solar chimney. People will experience the breathing of the building as the louvers of the chimney open and close throughout the day. Now, for the solar chimney to work, a series of operable windows along the building's edge will intake air. The air will transfer into the corridors and make its way to the breathing rooms. Natural convection and hot air inside the chimney will drive the air up and out. The solar chimney forms part of a number of sustainable initiatives, including daylight harvesting. And when the Arbour is built, it's projected to use only 65 kilowatt hour per meter squared per year of energy. Now, to put that in perspective, traditional buildings of this kind would use around 300 to 400. So this is a significant reduction of energy usage. The Arbour has both passive and active systems because it is extremely cold in the winter here in Toronto, and it's hot and humid in the summer. Two decentralized mechanical rooms are located on each floor, eliminating the need for a centralized penthouse. This will allow George Brown College to potentially close down the mechanical system floor by floor as needed to save energy. This also allows for the peak of the mass timber roof to be inhabited. The peak of the roof is expected to be the home of the Tallwood Institute that will be dedicated to the research of mass timber and have expansive views to Lake Ontario. A raised floor access system will provide fresh air during its mechanical mode, and radiant heating and cooling panels will optimize its energy efficiency. Now, the Arbour uses two main mass timber products. It uses glulam for its columns because of its great compressive strength, and cross-laminated timber, CLT, for its beam and infill panels. Wood has incredible strength compared to its weight, and understanding these products and the limitations of the products is extremely important when starting a mass timber building. Here's an example of CLT being prepared in a plant in northern Quebec. Cross-laminated timber is a series of dimensional lumber that is pressed with adhesive and vacuum presses. The lam or layers of wood lay perpendicular to one another in each lam, giving the CLT strength in two directions, as opposed to glulam where the layers are laid parallel to each other. Here you can see a slab of CLT that is being prepped with the holes to run conduit and piping, all done in the shop prior to arriving to site. For the Arbour, the innovation of the mass timber comes in its shallow, beamless CLT structure. It uses elongated glulam columns and wide CLT slab bands to achieve the 9.2 by 7.2 structural bay. The CLT slab bands are topped with concrete to provide a composite slab action, which help against rolling shear that the natural fibers of the wood will experience when under stress. This composite slab happens at the slab bands only, yet a 2-inch concrete topping is placed on the entirety of the floor in order to help minimize noise impact. Wood is light, and as a result, acoustics and vibration, including impact noise, needs to be a key consideration in the design with mass timber. The result is a system that minimizes floor-to-floor heights, and in a combination with a raised access floor, it minimizes impact of mechanical and electrical interference with the structural system. In achieving a 9-meter bay and in a shallow design, this system will be economical and desirable for many building applications in the future. The Arbour in its height and occupancy is above what the current codes would permit. And currently, even with the changes that are proposed in 2020 for 12 stories of mass timber here in Canada, those codes are allowing for residential and commercial occupancy only. Now, the Arbour is an assembly occupancy, which has a higher risk. The Arbour will seek code approval through alternative compliance, proving that the building is as safe as its counterparts of steel and concrete structure, which would be a permittable building material for this type of building. The structural members of the exposed mass timber, and in fact of all the mass timber that will be placed in the Arbour, is to be oversized by at least 2 inches of a sacrificial char layer. This will provide a 2-hour fire resistant rating, protecting the structural section within. As we know that as wood burns, it forms a protective barrier around its edge called this char. And so as the char is protecting the structural section within. There are a number of other aspects that are being negotiated with the city in terms of submitting the alternative compliance. They include sprinkler reliability, increased sprinkler density, and enhanced smoke detection. And all to say that negotiations and discussions with local authorities need to happen early because they may vary depending on your location. And these types of additional elements may also have impact on a project in terms of cost. Moisture control in mass timber is also very critical. In thinking about the construction, the best defense is to close the building up as quickly as possible to prevent moisture saturation and potential staining on the mass timber. Now, it's okay if wood gets wet, but it's important to allow it to dry out properly before any encapsulation occurs. The mass timber is prefabricated, meaning that all of its components will be made in a shop prior to coming to site. And once it arrives to site, it'll go up quickly. The Arbour utilizes also a prefabricated wall system that will be built off-site and installed in tandem with the mass timber. So as the mass timber goes up, the envelope will go up in addition to that. The prefabrication of mass timber can have many advantages. Now, it can reduce on-site installation time and overall schedule, which could reduce overall cost savings. It could result in overall cost savings. There may also be cost savings in terms of lending time on land. Opportunities for better quality control can be seen. Mass timber is typically built to a 2 millimeter tolerance, and there is a possibility for fewer change orders while on site. Another interesting aspect is that mass timber tends to be a quieter in construction. There tends to be quieter construction sites, as the grinding and cutting that would happen in steel construction sites are not happening on mass timber sites. This could have particular advantages for urban sites that, or any noise sensitive sites. Now, depending on where you are in the world, and the mass timber may be new for many areas, and the training of trades may be required, which in this case could lead to higher costs. So you want to understand the education of the trades in terms of mass timber and the construction of it. I read an article that in Austria, they're claiming that mass timber construction is as cost effective as steel and concrete, because they've been doing it for quite a while and have many resources around that. On-site modifications to the mass timber want to be avoided, and therefore these projects require enhanced coordination and interference well in advance of construction. The work that is being done during the design phase is more detailed. And the use of virtual design and construction modeling is an enhanced tool that can greatly benefit constructability issues. Virtual 4D simulation modeling can also have advantages in the process in design and construction. Now, there are also a number of other design considerations that should be mentioned. The use of full-scale mock-ups may want to be considered in order to sort out all of the details and construction sequencing before you get on site. You'll want to consider the fireproofing of connectors, and again, as I mentioned, vibration and acoustics should be greatly considered. You want to have early discussions with the approvals and the authorities having jurisdiction in order to understand any additional design requirements that may be needed. And also insurance companies may also have certain requirements, and you want to have early discussions or encourage your client and contractors to have early discussion with their insurance companies. Fire protection may be required, temporary fire protection during construction, and on-site security and protection. The supply chain is also one that should be thought of. There are a number of mass timber products that are available on the market, and each have their own benefits and aesthetics to them. And also to keep in mind that there are regulations and standards that apply to products. So for example, CLT to be used structurally must conform to certain standards. In Canada, currently, there are only 2 manufacturers that are certified to do this. We are expecting more to come online this year, but with the limited number of suppliers here in Canada right now, we're looking at about a year wait in order to receive CLT for construction. This needs to be considered in the overall project schedule. And with that, I'd like to conclude the discussion on the Arbour and move on to another example of mass timber. The Honeybee Research Centre is a project for the Ontario Agricultural College at the University of Guelph. It's similar to the Arbour in that it celebrates mass timber and sustainable design, yet it's a much different scale. It is a project by Moriyama Teshima Architects, and the team included Moses Engineering for structural, Integral for mechanical, electrical, and sustainability, and FORC for landscape architecture. The Honeybee Research Centre also started with an international design competition calling for an iconic state-of-the-art research facility dedicated to honeybee health and well-being, and a place to educate the community and share knowledge. The Honeybee Research Centre is to be located in the Arboretum of Guelph, a site that is ecologically diverse and rich with wildlife. Our proposal for the centre was rooted in its connection to the land and commitment to sustainability. The building became part of the landscape and became an extension of the Arboretum. As we started the project, we learned that there are 4 major reasons to the decline of honeybee colonies, and they include climate change, reduced habitat and poor nutrition, often resulting in lack of biodiversity, exposure to pesticides, disease, pest, and genetics. Honeybees are a very important part of our ecological agricultural system, and in Canada, they are a major pollinator where we rely on 1/3 of our food crops to be pollinated by honeybees. The center was comprised of 3 major components. It was a research area that was both inside and outside. There was a production for the extraction of honey, and there was an education and discovery area. And in the center of this, the building was to provide an experience for the visitor, and the building to promote a sense of a living laboratory. The mass timber roof structure lifts and becomes an extension of the landscape, and the program spaces fit below. The extensive pollinator roof garden was an expression to the importance of promoting biodiversity, and its concept can speak to the potentials that building and rooftops can have to create biodiverse landscapes and environments all over the world, from urban centers to rural areas. A discovery trail that extends around the apiary and pollinator fields continue onto the roof and giving the visitors another view of the Arboretum beyond. The mass timber canopy that extends the building edge provides shelter for outdoor activities to occur. And as you make your way up to the rooftop, you get a view of the apiary and the Arboretum beyond. There's also an entrance to the interpretive tower at this location, which you can see in the structure to the right of the image. The interpretive tower is an observation deck, and it's also a solar chimney for the building below. And in the tower, visitors can learn about honeybees and the importance of pollinator corridors. The result is a building that is integrated and seamless with the landscape. And as you approach the building, the mass timber tower can be seen from a distance, as well as the pollinating roofscape. The entrance of the building leads directly into the Discovery Centre, where the mass timber grid structure is used in every aspect. The mass timber grid structure is forming the roof, the walls, and even the seats that people can inhabit. At the center of the Discovery Centre is a multi-purpose teaching space that could host a variety of functions and events. The expression of the mass timber was inspired by the handcraft nature of the bee box. The bee box provides the shelter to the bees, and the dimensions inspired the mass timber grid. And these boxes were imagined to be used in every aspect. The Discovery Centre flanks the research areas, allowing visitors to view into the research that is happening and the extraction of honey, to learn about those aspects without disrupting the work that is happening inside. To offset the costs of mass timber, the building uses an exposed mass timber grid structure in the public areas to really celebrate the visibility of it. And in the research and production areas where ceiling finish would be required, the building proposes a conventional wood frame construction there. The form of the building is purposeful to a sustainable agenda, and the tower doubles, as I mentioned, as a solar chimney to give natural ventilation to the building. The extension of the roof lines form canopies to shade the interior from direct sunlight. And there are other sustainable initiatives, such as a geo-exchange system, rain gardens, and earth tubes that all support the passive agenda for the building. And the idea of biodiversity and connection to the ecological systems extend to the landscape design. Bee fountains are integrated into the landscape, as honeybees require water to produce honey. Poplar groves are planted in the apiary, which bees use to create resin to seal up their home in the winter. Seasonal blooms will be planted and become a food source for the honeybees, and the taste of the honey will change according to the various seasons. And with that, we envision a landscape and building that expresses the importance of honeybees. I just want to thank you, and now I'm going to pass it over to Trevor to present some of his experiences with mass timber.
Thank you, Veronica. Thanks, that was a really excellent overview there of the Arbour and the honeybee project and some of the background on mass timber. I'm going to be going through some of the projects that I've worked on and some that I haven't worked on, just have the interest of as an engineer and seeing what is happening in the construction industry around us right now. So just from a starting point, from an engineering perspective, you know, the use of timber in buildings as a natural carbon sequestering material is a very positive option, especially with regard to climate change, this renewable resource. I think what we're seeing in the last 10, 15 years is that there have been some bumps along the road with using mass timber. Some of this prefabrication, there have been some issues, but this was sort of 10, 15 years ago, and it's no longer, I would say, at the bleeding edge of technology. It's now becoming more of a tried and tested method. And we're seeing that with the industry growing, setting up new plants, new systems to manufacture these components. Also the regulatory bodies with fire testing, structural loading, acoustics, and durability. It takes a while to shift the construction industry, especially with something innovative like this. So, you know, it's getting there, and we're seeing it being used more and more. And, you know, really, you know, this isn't like a brand new system. As Veronica showed, there are some buildings which are over 1,000 years old that use this. And I think that's true in a lot of engineering and a lot of architectural design. A lot of older systems kind of got forgotten about in the Industrial Revolution. And now we're seeing a lot of the more environmental, more sustainable approaches to design finding their feet in the modern world of construction. And one particular example here that I'm aware of and has been in quite a lot of the news by Perkins and Will Architecture in Vancouver, working with Delta Group as the developer. It's called the Earth Tower, and it's a 40-story wood tower, which would become the world's tallest when it gets constructed right now. It's about 32,000 square meters of accommodation, with 3 to 4 stories of podium at ground level, which includes commercial and working spaces, as well as some residential. And then a tower with different units of accommodation. Perched right at the top is a community space where people can share a common area together and have those expansive views across the ocean and the city and the mountains beyond. So it's the technology is there to do this. The only thing holding this one up at the moment is that it just takes a long while to go through the rezoning within the city. Vancouver is one of the busiest cities in Canada, and there's lots of projects on their books. So it's in the process. So I think within a year or so, we should see some movement on that. Here are some images which Perkins and Will have been kind enough to share. The one on the left there would be what a typical apartment could look like. Veronica mentioned 40% visible timber on the Arbour project. And this is sort of seeking to get beyond how far can we go? And, 40% is a safe target at the moment. By the time the Earth Tower is built, that may be more like 50, 60, 70%. I don't know, we'll see how that goes. The image on the right there is the rooftop community space, that large sort of city living room that will be created with a grid shell structure capping it off. And then, at ground level, there's the ability to, it's not just about the wood structure. There's a lot more involved here. There's the biodiversity, there's on-site stormwater management, there's food production, there's educational facilities, community program in this podium structure, and also access routes through for cycling and pedestrians. So it really fits well with the neighborhood, and it's a holistic approach to sustainability, which is embracing a lot of the goals that the developer is seeking to achieve. In fact, if you were to ask you to design a tower that was the most sustainable that it could be, it's probably going to look exactly like this one. So that's kind of on the large scale. And then Kamloops is a town in the interior zone of British Columbia. It's about a 2 to 3 hour drive from Vancouver if you head directly east inland. It's a town of about 200,000 people, and they're planning to build a new innovation center. Kamloops is in an area where there's a lot of forestry and paper mills and wood mills. It's an industrial city, and but it's getting more advanced with that forestry approach. And some of those, that map Veronica showed, showing where the new plants are going to be opening up for mass timber, Kamloops really sits in the heart of that area. And so to build an innovation center for the city, it really made sense working with Blue Green Architecture and Arbour Investments to build it out of mass timber. So the structural engineer, Robin here of ISL, has put together a structural plan. It's an 8-story building. There's a large glass atrium into the southwest corner there. It's various floor heights throughout the building. There'll be different program uses, some community use, some city commercial use. So it's a really mixed program, and it's on a brownfield site in the middle of the city. So, planning, it's in the planning stages right now. And as a as a jurisdiction, like a smaller city compared to one like Vancouver or Toronto, to work through the approvals process, as Veronica said, talk to the jurisdictions early on and make sure that you can work that out. And with Blue Green, they've really sort of led the way with that, with the developer and also with the city to talk through what the wood frame structure would mean on approvals. And you know, as an experienced structural engineer as well here. So it's coming together. The building also has some solar built into the facade for solar energy generation, some rooftop gardens, and the facade changes as you move around depending which orientation you're on, because it's important to allow good daylight and minimize solar heating gains. So there's two main strategies with the environment here. There's a mechanical mode, because here it does get sort of -30 Celsius in the winter, and in the summer it can be +40. So there's a need to have some mechanical mode, but really to work with the building itself to allow it to operate naturally and breathe naturally. Veronica mentioned that on the Arbour building, these breathing rooms. The sketch on the right just shows how we can open up the facade and allow the building just to naturally ventilate on days. Typically in the springtime, like it is right now in Canada, we could run this building with no mechanical systems. But that has to be tested through sort of some energy modeling. And this is some software that we use with the Athabasca University. And if anyone would like a trial of this, we can make that available to anybody. But it's calculating this carbon footprint and peak loads that we're interested in, and solar gains, etc. Because the facade on the building has to work well. So typically there will be a panelized system, and we're working with Paradigm Panels here, who make a passive house. This is also made in the factory. So the structure's made in the factory, and also the cladding. And once the envelope is worked out to the kind of amount of glazing and venting that we need, these can then be made with minimal wastage, and using this Stykoflex, which is this wood fiber insulation, we're really looking to achieve a net zero carbon approach here. The only kind of harmful product is that gypsum plasterboard. Everything else is coming from a natural source and helping to get towards a zero carbon strategy. The Canada Green Building Council have a zero carbon standard, and that Earth Tower is seeking to achieve it, as is this Kamloops Innovation Centre. So there's sort of another image of what the building could look like once it's finished. It's currently in the planning permitting stage. I'm going to move on to another sort of smaller town in British Columbia. This is in Squamish. If anyone's been skiing in Whistler, you'll go through Squamish on the way to get there, most likely. And this is a very popular community restaurant in the woods by the rivers, the Chikai and the Cheakamus River, where they join together. There's a beautiful restaurant just sitting there. And it's basically like a cabin, and it burnt down. The old building burnt down about 2 years ago, tragically through a fire one evening. And the owners have a very deep sense of sustainability. And they decided when they would rebuild that they would, rather than just go on a steel and concrete building, they would actually reuse wood again. Despite the fact that the previous building had been built of wood and it burnt down, they really believed in a low carbon solution and getting the right low embodied energy carbon sequestration. So this was the plan, working with Chris Hunter of Hunter Office Architects in Squamish, was to develop a kitchen building, basically. There's no internal restaurant space. There's a small enclosed bar, a very cozy nook for winter with a fire. But underneath there's seating, sheltered seating, open to the outdoor air, and a beautiful garden with play areas, etc. So the structural engineer Twin Peaks here came up with the DLT system, which is dowel laminated timber. There's no glue involved in this product, It's just held together by wooden pegs, in dowel pegs that you can get at any hardware store, basically. They're probably a bit more advanced than that. But this is what it looks like as a structural detail. Structure Craft are one of those manufacturers where they make this product. It's basically pieces of 2-inch thick wood at various heights. This is about a 2 by 400 mil. So it's pretty, deep wood, but it's just pegged together by these dowels. And this is what it looks like in place. That the groove there is to allow for some movement and allow for to create a really nice aesthetic too. So this became the structural solution for the kitchen. And you go through the shop drawings, and as Veronica mentioned, working to get the right structural plan worked out early on is really important. And those blue, or those sort of diamond shaped squares there, those are the holes for mechanical systems. So early on, the mechanical has to be pretty closely coordinated with the structure and the architecture, so that when these mass timber slabs are made in the factory, they can be cut neatly and correctly finished. I mean, you can cut on site, but it's preferable to do it early on. So what was really great about the Arbour project was there was a very deliberate approach to a consistent mechanical and structural system, and that was enabled the manufacturing to be carried out simply. And here on this smaller project, we had to really develop quite a tight approach. So just going to show you a few images of the mass timber, the DRT panels coming in. It's really the flooring and the roof of the rest of the kitchen. You can see just the image on the left there. Must point out that mountain in the background. The whole kitchen is sort of directed to look towards that beautiful peak. So these just get craned into place. Here's the roof going on, and they come with a sort of protective waterproof layer on top. That black kind of edge you can see that goes along the top for transportation, and once it's in place and watertight, that can be removed. Veronica mentioned that getting these watertight early is important, but the wood isn't that fragile, but it does have to be protected pretty quickly. So this was going on all through the winter, through a -20 snow day to a brighter sort of early spring day. So provided you protect it once it's in place, it does come already protected to site, and that's been one of the learning curves that the supplier has worked on as we've kind of learned more about the product. And here's the finished building. I'd really recommend a visit there sometime. You can see the undercroft sort of seating area with the DLT, creating a very warm indoor-outdoor kind of space, and the views across to the mountain from the small sort of bar deck area. And then what I really like here is the biophilia of the way that the kitchen building really fits in with there's a beautiful sort of walnut tree there that kind of snuggles together with the building. There's a video here which I'm going to just try and show and just give you a bit of an overview. I hope this works. It's worth saying here that the building does have an earth tube ventilation system for makeup air. Kitchens use huge amounts of air for ventilation, so to actually preheat all of the makeup air can be quite an expensive choice. So the earth tube does that all passively and provides cooling in the summertime. Whoops. All right, let's just, we can skip this. Yeah, so that's really the Fergie's project, and it's a different scale to some of the other ones which we've looked at, but you can work with this mass timber on any scale. I think that's really important to know. And then the final project I wanted to just share was this Pender Harbour Ocean Discovery Station with Deutsche Architecture up in British Columbia by the ocean. It's a regular concrete foundation, and then there's a heavy timber truss or sort of archway structure, creating 3 pods, which all have different uses, and they're being developed as a very low embodied energy solution here. Miskamim structural engineers are leading the way on this mass timber system, and it's sort of currently going through a design review to hopefully get going. It recently received some funding, but the program here is to really express the mass timber I'd say like it's curved here rather than just a very rigid structure. So you can really play games with that, and some of those the examples that Veronica shared at the introduction to her talk really were very expressive in the use of mass timber. So, but it's part of the whole approach to sustainability and regenerative design. We've got to think about water and energy in operational terms. We're going to look at waste, biodiversity. So it's a whole systems approach that we need to take, and the mass timber is part of that. I always refer back to Herbert Giraudet, who talks about the need to be more of a circular metabolism in how we live and design and operate our communities, and rather than just a linear kind of consumable and producing waste. So mass timber has a big role to play in this as part of our structure. And some work that Anthony Pack and Priopta are working on, as buildings become more energy efficient, like towards net zero energy in their use, the relative impact of the embodied energy is going to be nearing, equal with the operational energy over its lifetime. So we've got to start considering that more and more. And there are various groups. I'm sure Anthony would be pleased to for you to get in contact with him through that Priopta website, looking at zero carbon, looking at embodied energy. And one of the things we tried to do, working with the city of Vancouver, was to say, look, if we were designing a building now, in 100 years' time, when people look back, will they say we were making good choices in what we did? In a way, it's like a backcast that John Robinson, Dave Waldron talked about at UBC. So the choices we're making today will have an impact into the future, and those who come after us will say, did we make good choices? Did we really do the right decisions? So that's just something to think about as we look at architecture, structure, engineering systems, and the choices that we make. And I think mass timber has a great role and a great future as we learn more about that. So that's all I had to share right now. Thank you very much.
Thanks a lot, Trevor. And Douglas, did you want to talk about the next event?
Yes, I would, Henry, if that's okay. But first I'm going to just to see, actually first I wanted to thank Veronica and Trevor for just a great talk. I also would draw attention to some of the tools that Trevor was talking about. Matchbox Energy is something that our students use. Trevor in the past has been kind enough to actually share it with other students around the world. It could form a component of our global studio as well. So we should be on the lookout for things that we could share together in order to move this concept forward. Again, I will suggest to people that if you're interested in the global studio concept, please contact me or Henry or any members of our Athabasca team. But I also wanted to share with you before, I know sometimes people tend to to leave during the question and answer period. And again, it's important though, I think, that people stay if they want to get the full certificate in terms of continuing education. But if you could bring up the slide again, yeah, I'm just going to check to see if Dr. Mappe actually might be online with us today, so that he might be able to talk a little bit about what he's going to be speaking about on June 25th. I'll just pause there for a second to see if he's with us today. Hearing, perhaps he's not with us, but I think this is going to be a very, very interesting lecture. We do have I would say one of our major issues moving forward is how do we start decolonizing architecture and design? We are still very much locked into a kind of a Western kind of mindset about architecture, and it's not particularly useful one for the world. So we need to address this. And what Dr. Mappe is doing here with his drawings and with his representation of ritual spaces, I think is critically important. And if we really do want to do a global studio, I think it's essential that we get many different points of view and that we hear from people all over the world. And again, that's a nudge that if you've got a particular point of view that you would like to share with our audience, we would really appreciate hearing from you. And we'll certainly make every effort to incorporate as many different sort of approaches as we possibly can. But I do encourage you to attend this lecture on the 25th of June. And of course, we'll be doing it in a similar way. But I also want to do a shout out to the open architecture people who are working with Dr. Mappe, and again to Kristen Kornienko, who was very instrumental in making this happen. So I'll hand it back to you, Henry. But again, thank you so much for organizing this, and thank you again to Veronica and Trevor for such a great lecture.
Thanks, Douglas. So thank you, Veronica, and thank you, Trevor, for your excellent presentations. We're going to move right into a Q&A session. And if you can, do you guys see the chat boxes and the questions that were asked?
Yes, I can see it.
Okay, so I'm going to just scroll back. I think the first question came from Darcy Kutrick at 9:24. She says, building safety codes officer here. Question, how common is 2 layers fire resistance rated gypsum board to encapsulate structural members? Alternative solution or new code compliant? I think you would be able to answer that. Veronica, right?
Yes, well, that's a great question. So, you know, what I understand is that many of the additions and new upgrades to the codes are put in place with the requirement that mass timber should have encapsulation. I'm speaking to some of the experience of Canadian code upgrades. There have been many demonstration projects over time. One that comes to mind is the Tall House Tower at Brock Commons, which was a encapsulated mass timber project. It formed part of the way in terms of some of the alternative compliance requirements that the new code that we'll be seeing in 2020 or expected to see in 2020 will release. So encapsulation is part of what we understand as the new code requirements. And I understand that there are some opportunities to have some exposed mass timber to be included in projects, but under certain conditions. So exposed mass timber is not something that is completely recognized by the new updated codes that we're projecting for, but we're seeing that the allowance for it is greatly starting to become more and more over time. So right now, encapsulation and a percentage of exposed is what we're expecting to see in the 2020. And we can't be for certain until it's actually released, but that's our anticipation.
Thanks, Veronica. Trevor, did you want to add to that, or we're okay?
No, I think Veronica answered that really well. I just would say that, you know, if there are going to be code questions that come up on the use of this mass timber material, but the industry is really gearing up to to help, to help work through those solutions. That's not really an area that I'm particularly involved with, but I do know that there are a lot of attention being given to this at this moment in time. I'd say that the other thing I'd say is that mass timber is the companies in Canada do export around the world. I know they've exported to Africa and to Asia and Europe. So it's a product that is sort of a growing industry that is being developed internationally.
Great. Okay, so let's move on to the next question. I think it's related as well. Mark Dolan at 926 asks, 2 types of X layers are standard, but is it really needed for mass timber?
Well, that's a great question. It's difficult for me to answer that, but there are many laboratory studies and burn tests that are done proving the capacities of mass timber under fire and the fire resistance rating. As I understand, I'm not a fire engineer, so I just want to qualify that. But as I understand that wood burns at a fairly predictable rate, so you're able to calculate the char layer, which is in the Arbour, we've allowed for a 2-inch char layer so that the structural member is secure if there is ever a fire. It'll be secure for 2 hours so that people can escape the building. Is it necessary? Well, it's hard to say that, but I think, theories of char prove that wood can withstand fire if it's of a certain section. The 2 layers of fireproof drywall, type X, which is often known as, is part of what we're seeing this coming out. So as more and more projects are done, there will be more and more studies and tests done. So I can't really say either way, but we're seeing laboratory tests that are, resulting that mass timber can withstand fire based on char.
Okay, so the next question comes from Dimitar Dobrev at 934. We might probably need some help from our South African friends for this one though. Who are the main distributors of mass timber in South African region?
Yeah.
Or anyone from South Africa, if you guys know.
Yeah. Unfortunately, that's not a question I can answer, but I know that there's a lot of European distributors of mass timber, especially in the Austria region. But that's a great question.
Well, all I'd add to that would be that whenever I hear from one of these manufacturers, they're always telling me about the projects and the systems they're exporting around the world. So if you're looking to maybe start a new distribution opportunity, that might be something you could look at, Dimitar, as well. But just get in touch with the companies directly that were listed on Veronica's slide and that I also referred to.
Okay, so at 9:39 we have Amanda Lang who asks, the use of a box design inside the Honeybee Center instead of a hexagonal pattern, was that more of an aesthetic or a constructability decision?
Yeah, that's a great question. It's a question that we debated as we were putting the design proposal together. For us, it was a bit of both. The box structure allowed for an easier construction, which would help reduce overall construction costs. But we were very drawn by the idea of the honey super and the honey bee hive, which is the box hive. For 2 reasons. When we visited the Honeybee Research Centre, we actually saw the head researchers and people on site actually making the box, and it had a very beautiful handcraft nature to them. And the bees lived in this and were sustained in this. And they actually were sustained out in the winter time, if the hive was strong enough, over pretty extreme cold conditions. The box was their shelter. It was their home. And so that really became the inspiring element of the box design of the mass timber. In addition to that, it is a more cost-effective solution than constructing a hexagonal grid-like structure.
Great. Then we have a comment from Arash D. Great comment. I think we're, Athabasca University being a university in Alberta, we are very interested in the situation and the conditions in Alberta. So we are keeping a close eye on that development. Then scrolling down, Dimitar Dobrev asks at 9:41, how third world friendly are these setups to make mass construction systems?
Yeah, I think that's a great question. It's a very interesting question to look further into. I think there are a number of factors that go into mass timber buildings, and supply and demand is definitely one of them, and where supply is coming from, forestry conditions, and I will also add forestry practices. And I think that should be an important point to note that sustainable forestry practices are very important when considering mass timber projects. But it also is a factor of the industry in the local areas and how well known the trades are in terms of constructing mass timber projects. So I think there's a lot of factors that go into the economics and of mass timber into different locations. And we're seeing that countries around the world are really pushing boundaries and embracing mass timber, but everyone is going through the same type of learning curves in terms of the logistics. So I think there are a number of factors that would probably play into answering this question a bit further.
Just add that it's another option to consider. It's proven structurally as a system, and it's another option to concrete or steel or other building systems. So worth looking at.
Okay. Next question from Amanda again at 9:49. In these natural ventilation systems, roughly what proportion of passive to active operation is currently possible in Canada? I think that was related to your project, Trevor.
Yeah, probably related to Kamloops, right, Amanda? The climate zone that we're in, I think we can really push this and really expand that shoulder season when we need to stop heating buildings and we don't need to cool them yet, and then similarly in the fall. So a lot of it comes down to the quality of the build and the envelope and the way that's put together. And I did rush over that a little bit on the Kamloops project, but we've got to get the right envelope to start with regard to solar orientation and prevailing winds and insulation details. But I think, really we should be able to operate, minimum 6 months of the year in completely passive mode. I would see that really from the end of March, probably through mid to late September. There'll probably be some, then with climate change and warmer days, we'll need to think about how we provide cooling. And the ability to passively cool is something that we should really spend some more time looking at together, perhaps in another lecture. But passive cooling is going to play a major important role with the buildings. And you saw on the Arbour there that the solar chimneys, the way that's providing passive cooling as well. But that atrium on Kamloops was a significant part of that, and the ability to bring in air through the underground earth tubes to also cool the buildings we saw on Fergie's also. So let's aim for 6 months to start with and work, trying to see how far we can expand it.
And For the Arbour here in Toronto, our weather conditions are more extreme. We have extremely hot summers. Today we're experiencing 30 degrees and 60% relative humidity. And the winters are extremely cold. So our shoulder seasons are less than that. And so we are projecting, though, for the Arbour about 4 months of the year that passive ventilation could be utilized. The building also has ceiling fans that are placed around the entirety of the building. And the idea of that is that the ceiling fan, if the air circulation occurs, perhaps we can raise the temperatures of the thermostat just a little bit more so that we still feel comfortable, but maybe it doesn't need to be at 21 degrees. Maybe it can be at 24 instead. So something as simple as a ceiling fan can help that. Another aspect of the Arbour's ventilation system is that it's user controlled so that you have the ability to open or close the windows as you're in the classrooms and whatnot. And the system will work on half a floor at a time. So if the window's open, the mechanical system will shut down for half of that floor because of the decentralized mechanical system. So it's just looking at zoning a little bit more carefully and thinking about what really is our thermal comfort threshold.
Great. The next question that we have at 9:54 by Kathleen Crizel. Are there any issues with the DLT system due to the loads transferring to the dowels between the wooden slates?
I would refer to Stephen's answer on that at 9:57.
Yes.
It's been well tested by probably one of the best wood structural engineers in North America at Fasternet. They developed the system and established Structurecraft sort of through that relationship, and so yeah, it's been well tested, and they've found a way to make that work okay.
Great, thanks, Stephen, for the answer.
Yeah.
And, Amanda asked at 9:55. It looks like that is Sho Sugiban finish on Fergie's Cafe, so charring of the timber.
Okay. I don't think it is charred timber, but I'd need to check on that. It could be in certain areas. I know that the finishes, we could check with Chris Hunter to see what it was, but it was maybe.
We'll check on that one, Amanda. We'll let you know if you're still would like to know the answer. We'll email you later. I received a question in a private message here by Tredegar Kennedy. He's asking, is carbon cure technology used in any of these projects to reduce net carbon footprint of the concrete to zero? Carbon cure technology.
Yeah, I think that's a great question. Right now, the carbon cure is not used in the two projects that I've worked on, but it's something that I'm personally interested in learning more about and understanding the specifics about, because I think there's great opportunity. Every building, well, in Canada at least, or probably around the world, needs some type of concrete. So I think it's a great opportunity that is starting to emerge.
Yeah, as far as I know, we didn't use the carbon cure concrete technology. For those who don't know what it is, it's a way of manufacturing the cement mix that goes into the concrete, which absorbs CO2. So it's really turning the concrete industry or cement making industry on its head by, rather than being one of the biggest emitters of carbon emissions, it can actually become a serious absorber of carbon emissions. And it's based in Nova Scotia, carbon cure, and be worth just to explore, some more info on that. It's a fascinating product.
Okay. At 10:01, we have Amanda who asks, Trevor, what were those literature resources that you cited just after the Pender Harbour?
They were, I'll have to look them up, but if you were to search the backcasting with John Robinson, Dave Waldron and Alberto Caella, you would find their paper on that in relation to University of British Columbia, UBC. You'll find the paper there. The previous reference was some work that Martina Sutherland and I had carried out with the city of Vancouver in developing some review of how they manage their assets, and with a plan to rationalize and plan for the future. So that's what it was really about. It came through a discussion with the city on how to make good decisions now to look back in 100 years and say, were they good decisions? So it's more of a point of reflection that I think as practitioners and academics, we need to keep aware of that ability to reflect backwards and think about what the impacts of what we're doing right now on those who come after us will be experiencing. So that isn't published in a paper anywhere. It's more of a discussion that we'd like to continue to expand upon.
Great. Then we have a couple of questions. Sean is asking if this video is going to be available to watch later. So yes, we are recording this lecture and we will post it in our YouTube channel shortly. So we will give you the link to the video if you're interested. Then we have Dimitar Dobrev, who's asking if we could include contact details for the Global Studio Lecture Series. If you have registered for this lecture through our registration system, you should have already my email address on the confirmation email. So you can email me if you have any questions. And also, after having registered for this lecture, we will also invite you, send you an email with an invitation to our future events. So you would also be able to contact us and register for future events through our mailing list. At 10:03, Mehdi's Ahead is asking a question to Veronica. Veronica, thank you for your presentation. BIM is the progressive approach in architectural design and the way of collaboration in today's AEC industry. Do you know any practical plugins for BIM tools to cover mass timber envelope properties and generate constructible details? Do you see the needs of architectural design technology courses for BIM applications on this topic?
Yeah, you know, it's a great question. The use of BIM types modeling is kind of critical with mass timber projects because of the highly coordinated nature of these types of projects. We used BIM on the Arbour for many different reasons. One of them was also to collaborate with our consultants that were located in the, and our collaborative architects located in the West Coast of Canada, and we're located in the eastern area. So we've used these type of BIM programs for that reason. And in terms of specific plugins for envelope properties to generate constructability details, and I'm not right now aware of any plugins. I'm sure there may be some. For projects like the Arbour and the Honeybee, the development of the exterior was specific for the project. And the thermal performance and the details were specific to how the project is designed in terms of structural system and its connections and how it's all coming together. I think it would be great to standardize some details, but I'm not aware of any plugins, but I'm sure there's probably something out there right now. There's also companies that provide extremely enhanced coordination, like CAD makers, where they will provide detailed models that are so detailed. model every nut and bolt if you wanted them to, in order to do that enhanced coordination as well. So BIM modeling and various means of BIM modeling is important. It's actually one of the ways that mass timber has really advanced over the years. But I'll definitely keep my eye out for some opportunities for and see if there's any plugins.
Okay, I have a private message here sent by Jean Dejnica. Are metal connectors separately fire rated?
Mm-hmm. Yes, that's a great question. So, you know, you might have seen in some of the precedent images that you saw that metal connectors on the top and bottoms of mass timber to help with certain aspects of, first of all, connecting the system together, but also in terms of compression of the system. The metal connectors, depending on the amount of exposure, do need to be fire rated as well, especially if they're supporting a structural system. If they're hidden fasteners, which means that they're kind of embedded in the mass timber, then the mass timber in itself, if it's rated with char or encapsulated, can provide that. But if the connector is exposed perhaps at the base of a column, it does need to have fire rating. So you would need to look into encapsulation or packing it with some type of fire rated insulation and other acceptable means to fire rate the steel. There's a lot of discussion on whether intumescent paint actually is an appropriate kind of means of fire rating steel when it comes to mass timber, and some fire engineers are not thrilled with that solution. So it's definitely something that has to be considered and done, and considered well with experts in the field.
Okay, given the time, I think we'll take one more question. And to answer some of your inquiries, so again, the lecture will be on our YouTube channel. And if you have any further questions, you also have Veronica and Trevor's email on the screen right now. So if you would like to address any questions to them later on, or if there's any questions you want to address to me related to the lecture series, you have that in your inbox as well. So the last question we'll take is Shanda at 10:06 is asking, I would like to know more about the carbon sequestration properties of the buildings. Does the carbon get released back into the building, or does it stay trapped in the timber?
Yeah, that's a really great question. So the idea of carbon sequestration in mass timber and in wood is that it would be trapped in the wood fibers. But considerations for end of life and end of use of mass timber should be considered. Thinking about ideas about recycling of wood. So it would not, the idea is that it should not release the carbon while it's in place, but if the wood starts to decompose, then that carbon would be released, just as if it were a tree in the forest. If it dies, the carbon is released. Or if there's a forest fire, the carbon gets released. So ideas about what happens to mass timber at the end of use is really important to consider. Building materials in this type of application, if done well, should last, 100+ years. But thinking about maybe opportunities for biomass fuel afterwards or other ways to recycle and reuse mass timber is part of a discussion that, that is happening in terms of what do we do afterwards, thinking about 100 years plus.
Okay, so I think we'll stop here given that we are out of time today. So again, I would like to take the conversation offline. If you have any other questions for Veronica or Trevor, feel free to email them. I will also share the chat conversation to them. So if it's okay, I'll ask Veronica and Trevor to also answer you via email. So thank you very much again, everyone, for attending today. Again, we'd also like to mention that we will be providing certificates of completion to those who require one for continuing education credits. So if you would like to receive one, we will be giving them to participants who have attended the whole session. And you can get in touch with me or Emma, who will be delivering you those certificates. So again, thank you everyone for attending, and we look forward to seeing you at the next event on June 25th. Douglas, did you want to say something to end?
Other than to just say thank you to everybody for participating, and in particular, thank you again to Veronica and Trevor and Henry for making all of this happen. I look forward to seeing you all at the next event.
Thanks, everybody.
Thank you.
Thanks for joining.
Thank you. Bye-bye.
Bye.